Welcome. Today, we're at the Peterbilt manufacturing facility in Denton, Texas to highlight some recent electrical enhancements that have been made to the models 567 and 579. In October 2018, Peterbilt introduced an additional electronic controller known as the VECU, or Vehicle Electronic Control Unit, which increased the capacity and processing power of the truck's electrical system. This also further integrates the MX engine with the truck's electrical system, increasing the flexibility and functionality for your specific applications, especially if you're integrating vocational bodies, PTOs, or aftermarket truck equipment with the chassis electrical system. Let's take a look. In this section, we will take a closer look at the chassis interfaces that are available to simplify vocational body integration with the truck's electrical system. There are several methods of communication between the chassis and a vocational body. They are hardwired connections, J1939 CAN bus, and TSC1 messaging. All of these methods are available on your Peterbilt truck. Now, CAN bus communication on Peterbilt model 567 and 579 is available with multiple communication speeds. Most body equipment is currently using a 250 kilobaud speed. However, some equipment is moving toward a faster 500 kilobaud speed. To match the speed of the body equipment's controller, dedicated harnesses with either communication speed must be selected on the truck's order spec. It is important to know which speed is required to be compatible with your equipment. If you're not sure, the safest path is to include harnesses for both speeds. Next, let's look at the body connection harnesses that are available and where they're located. First, this most basic example is if your vocational body only requires power and ground to operate lights. In this case, an electrical junction box can be added to your truck spec and will be located on the driver's side frame rail behind the cab. Second, if you use a PTO to operate a pump or other equipment, a 4-pin connector harness will serve as a feedback loop to verify the PTO has been engaged. If you require the use of 2 PTOs, this 4-pin connector now has the ability to provide verification of both PTOs' engagement independently. Third, if your application requires the use of a hardwired remote throttle or remote PTO control station, then your truck will need to have a 12-pin connector to communicate these signals from your remote station to the chassis electrical system. The 12-pin connector can be located in one of 3 locations, whichever is most convenient for your equipment integration. Those locations are in the engine bay, behind the cab, or at the end of the frame rail. Fourth, if your PTO operations would benefit from utilizing specific preset speed settings, an 8-pin harness and connector must be included on your truck spec. We will discuss the preset PTO speeds in more detail in a later video, but this 8-pin connector will carry the preset PTO signals. This 8-pin connector is also required if you want to use custom installed interlock functionality for PTO operations. For example, if you want a proximity switch on the vocational body to act as a safety interlock before entering PTO mode operation, you will connect the signal from the proximity switch to the 8-pin harness. Finally, if your equipment communicates using the CAN bus network, J1939 connections are available beside the 12-pin connectors located behind the cab or at the end of the frame. For in-cab connections, an industry standard RP1226 connector is always available inside the dash right behind the OBD diagnostic connector. This can be used to connect to any equipment that needs CAN bus information, from telematics devices to a body controller inside the cab. In the next video, we will look at the basic switch configuration on the dash. For more detailed information, visit Peterbilt.com. Under the Resources and Support tab, you can always find the latest version of our bodybuilder manuals.